Hi, Chris Kuzmal here, continuing on the topic of logic. We've just covered the syntax of propositional logic. Now we're going to talk about the semantics of propositional logic, which involves the idea of assigning true or false to each simple sentence and then defining how a logical operator affects whether that logical sentence is true or false. So first we assign a truth value to a proposition. So we might have a proposition P, and we might give an assignment to it that is false, or we might give an assignment to it that is true. And so when we give assignment 0 to P, that logical sentence has a truth value that is false. When we have two propositions, there are four possible assignments. So if we have proposition P and proposition Q, they can both be false. P could be true and Q could be false. P could be false and Q could be true. They could both be true. Thus, there are four possible assignments. Negation operator reverses the value. So if we look across this, we see P, Q, and then not P and not Q. So every time we have P false, not P is true. Every time we have Q false, not Q is true. And similarly for every other possible assignment, all the negation operator does is reverse the truth value. The disjunction operator, which is a big word for an OR operator, generally gives you true. Whenever it can, it gives you true. But when they're both false, when both P and Q are false, the disjunction of them remains false. Every other case causes us to get a true value for the resulting logical sentence. The conjunction operator is, in a sense, has the opposite sense from the disjunction operator. Anytime you have a false in either P or Q, then the whole logical sentence results in a false. Only if both P and Q are true will you get a truth value that is true for the logical conjunction. The implication operator is a little bit counterintuitive. It is always true except for one case, and that is where P is true and Q is false. Every other circumstance results in the logical sentence P implies Q evaluating to true. The biconditional operator essentially compares the P and Q, and if they're both the same, then the result of the biconditional is true. So when they're both false, the result of the biconditional is true. When they are different from each other, the result of the biconditional is that they are false. And when they're both true, the biconditional is true. More complex sentences build on this. So here we have two reasonably complex sentences, P or Q and not P, and then we conjoin them, and that results in a truth value that is a function of the conjunction operator that we looked at before. So here we see the truth table for that more complex sentence. Now then, an assignment that makes a sentence true is defined as being something that satisfies a logical sentence. So here we have a set of propositions and a truth assignment that causes the rightmost proposition to be false. And then assignment 1 is false. But assignment 2 causes the logical sentence to be true. And that means assignment 2 satisfies the logical sentence P or Q and not P. When an assignment makes a sentence false, that means it falsifies it. And so the 0th assignment causes that logical sentence to be false. Oh, and there's some other assignments that can also cause the logical sentence to be false. When we have a set of sentences, then when one sentence is false, that falsifies the entire sentence. When all sentences are satisfied, that means that the set of sentences are satisfied. And that gives you everything about semantics for propositional logic. Once again, thanks to the Stanford Logic Group, Professor Janesarith and Professor Chaudhry.